Hi there. In the previous lesson we talked about angles that are formed when two lines are cut by a transversal. Today we want to narrow our focus a little bit to see what happens, and there are some real numerical relationships that happen when the two lines that you're cutting by the transversal happen to be parallel. So I want to just remind you that we are showing lines M and N parallel in this diagram by these arrowheads. That's the symbol for, yes, we run in the same direction. And we're going to begin our discussion with a postulate about one of the types of angles here. And I'll just remind you that a postulate is a statement that you accept as fact. It cannot be proven deductively, but you can use postulates to prove other things. So we're going to begin with postulate 3.1, and that one is about when two parallel lines are cut by a transversal, then each pair of, and you'll remember this angle type from yesterday, same side interior angles are, and here's the deal, they are supplementary. And you'll remember that that means they add up to 180. So that would mean that in this diagram, angles 3 and 5 would add up to 180 degrees. This is a postulate, and we're asking you to accept that fact as the truth. Same side interior angles add up to 180 degrees when parallel lines are cut by a transversal. We next want to talk about same thing, when parallel lines are cut by a transversal, then each pair of, and now we're going to go to corresponding angles here. Each pair of corresponding angles are, and I want to just direct you to the diagram, that would be something like this, 2 and 5. And what we're going to find out, and what we can prove, is that they have to be congruent. Same side interior angles are supplementary, but corresponding angles have to be congruent. The next theorem, same situation, we have two parallel lines cut by a transversal. Now we're going to talk about alternate interior angles. Each pair of alternate interior angles, and that would be like 3 and 6, they are also congruent. And we are going to prove that theorem. So I want to have you walk through this with me. We are given here that line M is parallel to line N. So I'm going to ask you to go out there and put the arrowheads so that you're marking your diagram. We have statements already given. So we begin with what we know, and that's that we start with two parallel lines, M and N. Step 2 says that when you add together angles 3 and 4, you get 180 degrees, and I would ask you to think about this. Why is that? What kind of angle pair are angles 3 and 4? And I hope that you're leaning in this direction. That's a linear pair. Okay? They are adjacent angles. They share a vertex and a side, and their outside edge makes a straight line. It's also true that angles 3 and 6 add up to 180, and those, folks, are our same side interior angles. So I'm going to write that as my reason, same side interior angles, and what we know about them is that they are supplementary. Okay, same side interior angles are supplemental. Now, as you look at the next line, this should remind you we've seen the same structure in other proofs. We had two things that each equal 180 here. They must be equal to each other, and that is a substitution step. In the back of your book it might say transitive. I like substitution. Now, the next step has angles 4 and 6 being equal. So how did they change? What's different in step 4 from step 5? And if you notice, that measure of angle 3 was on both of those, and now it's not there anymore. So we must have subtracted. We used the subtraction property of equality and subtracted the same amount from both sides of an equation. I'll write the word property, although I got to tell you, if you don't write that, it's not a big deal to me. Lastly, we have angle 4 congruent to angle 6, and those are the alternate interior angles that we were interested in. This step moved from an equals to a congruency marking. Folks, that is the definition of congruent angles, and I'm going to just write definition of congruency. So there's a little proof of the alternate interior angles theorem. Notice that we use the postulate in order to solve the theorem. And now we have some practice problems that are going to ask us to find the measures of things in the diagram based on sets of parallel lines. In this diagram we have two sets. N and M are parallel, P and Q are parallel. So we're going to have to be a little bit picky as we look at this diagram. The first question asks us for the measure of angle 3. So as you look over here, there's angle 3. All we know is this 105. So if we can figure out what kind of angles those two are, it will help us. Yeah, what are they? Let's see. P and Q are the two lines. M is working as the transversal here. They're on opposite sides in between P and Q. You guys, those are alternate. So here's, we're going to answer both of these questions at the same time. Alternate interior angles tell us that angle 3 is 105 degrees. Okay, it's alternate and interior with that angle that's measured. Next we look at angle 4, and I'd like you to do a similar kind of thinking. I am going to ask you to pause the video and come up with a measure for angle 4 on your own. Alright, you can see my work here. This time N and M are the two lines, Q is operating as the transversal, and these guys are on the same side of the transversal in between the lines. That means they have to add up to 180, so angle 4 has to be 180 minus 105 degrees, and that's 75 degrees. Good. Same picture. Now we're going to just ask you to find the measures of several angles, and knowing the measure of one in this diagram will let you find the measures of all the others. Angle 1 over here. Well, you've just said that angle 4 was 75, and 1 and 4 alternate interior, so I hope you're thinking 75. That's the first one. I want you to stop the video and figure out the measures of the other angles. Alright, here are my results along with the justification for each. Angle 2 is vertical to angle 1, so I know that it has to be 75 degrees. Angle 5 corresponds with the 105 degree angle. That means they are the same. Angle 6, alternate and interior with the 105 degree angle, so equal. Angle 7, vertical with the 105. And angle 8, now this one you had to work a little bit at. We know that angle 4 was 75 degrees, and so angle 8 is same side interior with that. It must be 105. Good practice there. Good job. Alright, we have just a couple more things to do here, and these are similar to problems that you will see on your assignment tomorrow. So we've got an object here, a trapezoid, since it has one pair of parallel lines. And those parallel lines are going to be important to us. In fact, I'm going to take my pencil and just extend the parallel lines as well as the transversal, because now this looks like our problem. We're supposed to find values for x and y. And as you look, if this is parallel and there's the transversal, they're same side interior angles. You guys, what's the relationship? They have to be supplemental. So that 2x angle plus the x minus 12 angle have to be supplementary. That means they add up to 180. I'm going to ask you, well, no, I'm going to do this. So now we're going to combine our like terms. We're going to add 12 to both sides. 3x gives us 192, and we divide by 3 to find a value for x. That's going to be 64. X is 64. I am going to ask you to stop the video. I want you to find a value for y. You use the same strategy. Okay, those two angles are same side interior. That means they're supplementary. So 3y plus y plus 20 equals 180. Doing a little algebra gets us to a y of 40. We're not quite finished yet. We're asked to find the measure of each angle in this figure. And we can do that by substituting back in the values that we found for x and y. So in the upper corner, 2x, that'd be 2 times 64. That guy is 128. Over here, y is 40, so 3 times 40, 120. And my claim is you have two ways that you could find the other two angles. You could subtract what you've gotten from 180, since you know together they have to add up, or you could do what we just did, which is substitute. This corner would be 64 minus 12, which would make it 52. Quick check, does that add up to 180? And over here, y plus 20, so 40 plus 20, that would be 60. And that also adds up to 180. Good job, folks. Good job. Important relationships when parallel lines are cut by transversals. We will use this really the rest of the school year. So get out there and try that. You try, and we'll see you in school.